All right, so lesson 4.2, reducing fractions. So last time we were just for what are some fractions that are going to be equivalent, and that's what we're going to do with our kickoff, and then we'll build from there. So to do this, here we're looking for so what would 1/6 be equal to if we had 18 for a denominator? Well, how many times would we take times 6 to get 18? Well, we'd take 6 times 3 to get our 18, so we're going to do the same thing on top. 1 times 3 gives us our 3, and that's what would be missing on the top. Let me write it here so you can see. Okay. So what we're doing there is we're just finding what makes these equal. We could have been going bigger, could have been going smaller. We're going to use the same idea, but now we're going to be trying to reduce them down to make them as small as possible. So a reduced fraction is an equivalent fraction that has the numerator and denominator as small as possible. So 4/6 in lowest terms. Well, both of these are even, so we know we could take 4 and divide it by 2, and we could take 6 and divide it by 2. 4 divided by 2 would be 2, 6 divided by 2 is 3. Those are both prime numbers. We can't make them any smaller. Write 3/4 in lowest terms. So, can 3 get any smaller? No, it's prime. So if the top can't get any smaller, we can't make the bottom any smaller, even though we can make the bottom go down to a 2, because 4 is even. We have to be able to divide the top and bottom by the same thing in order to reduce it. If we can't divide them by the same thing, then we can't reduce. So here, 3/4 is the lowest terms. We can't make it any smaller. 10/35. So here, 10 ends in a 0, 35 ends in a 5. The only number that can be divided into a 0 or a 5 is 5. So that's what we're going to do here. We're going to go 10 over 35, and we're going to divide the top by 5, and divide the bottom by 5. 10 divided by 5 leaves us with a 2 on top. 35 divided by 5 is a 7 on bottom. Now again, those are both prime. We can't go any smaller. There's nothing in common between the two either. Now, write 231 over 238 in lowest terms. Now, here is one. Looking at this, you're going, wow, those are big numbers. I don't know something off the top of my head that's going to go into it. Well, let's start going through some of those rules of divisibility. Are both of them even? Well, the bottom is, the top is not, so we can't divide by 2. To divide by 3, we would add the 3 digits together and then divide by 3. If that works, then we could divide it by 3. So 2, 3, and 1. If we add them together, 2 plus 3 is 5, plus 1 is 6. 6 we could divide by 3. So right now the top is divisible by 3. Let's see if the bottom is. 2 and 3 would make 5. 5 and 8 would be 13. 13 is not divisible by 3. That will not work. So, so it's not even, it's not odd, so we can't divide it by 6. We're not going to be divisible by by 4 either, because our last 2 digits here are 31, not divisible by 4. 38, not divisible by 4. It's not 5 or 0. So here, again, a little bit harder. So here's what we're going to do. We're going to take our calculator here, and we're going to start trying some different things. So we know we can't do up to 6. So what about 7? So 2, 3, 1, divide 7. Hey, we get a whole number there. So let's see if it works on the bottom. 2, 3, 8. If we divide it by 7. There we go. So sometimes, you can kind of start going through like, okay, can I do this? Can I do this? Can I do this? And then sometimes it's going to be easier just to take your calculator and start going, okay, can I divide it by 7? Can I divide it by 8? Can I divide it by 9? Until we find something that works. So 231 over 238, we're going to divide by 7. And so we have 33 over 34. Now, once you do this, each time you should still go through and go, okay, have I reduced it to the lowest I can, or can I go any further? Well, 33 is 6. We could divide by 3. 34 though is 7, not going to work by 3. They're both not even, can't divide by 2. You know, we could divide the top by 11, the bottom's not going to work by 11. You know, we're going to get to where we're really not going to find anything that's going to work between these two. So this is going to be the lowest it's going to go. But what I want to point out is this is an extra example, but I want to give you an idea to try when you're doing these. Let's say we have, let's go, what's a good one? 18 over 24. Okay, so this one here, I can look and I go, okay, I know I can divide these by 2. So divided by 2, since they're both even. And so we're going to end up with 9 over 12. And I go, wait a minute, I can divide both of those by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. Now I know 3/4 is already lowest term, so I can't go any further. But the point I'm making is if you go through, excuse me there. If we go through and we know we can, hey, these are even, I can divide it by 2, I can reduce it down to a number and go, oh wait, you know what? I know another number I can divide into those. And you can keep reducing down until you can't go any further. You don't always have to just from the start go, oh, I know this has to be a 7, and I'm going to divide them all by a 7. You can find some smaller ones that you know work. Divide those out, get them a little smaller, make them a little easier to work with. All right. So, have any questions, let me know. Otherwise, we'll talk to you later.